Ladies and gentlemen, boys and girls, programmers from all over the world, PHP, JavaScript, who knows, who cares? We're going to design a programming language. This is Daily, episode 29. I am assertchris, or just Chris, you know, whatever. And today I thought I'd do something really interesting, because basically, when I tell you I've prepared for this, all I've done is imagine what kind of things I would put into a programming language of my own. I am not qualified to design a programming language. I have never designed a programming language. And there are very popular speakers in PHP and in JavaScript who have done these things and who have written compilers to boot and are really, really clever people and far more qualified to do this. But I thought this would be really fun. And there are some things that I want to try and achieve, and I'm probably not going to get through designing anything nearly coherent in this daily. But I still want to try. So we're going to do the usual 3-part, 20-minute segment thing. And I'm basically just going to waffle and look at what other programming languages are doing and try and construct a little bit of a spec. And what we've got to begin with is just an empty text editor. That's it. So let's talk about, let me talk about what I think the goal of this thing should be. I've been writing some posts about making compilers in PHP and in JavaScript, and last week I did a talk at FluentConf, which was in San Francisco, a JavaScript conference, a front-end conference, and it was one of the weirdest talks of the conference. I did 2 talks actually. So the one was about programming in Minecraft, which is a pretty weird talk, and I did some streaming stuff about this a couple weeks ago. And the other talk was on creating a compiler in JavaScript. And what I basically did for 90 minutes was talk people through using something like, using JSBin, essentially, and making a lexer, a parser, an interpreter, and getting a single line of programming code to go from just being a string to actually executing as a program. And it worked brilliantly. I had so much fun doing it, and the people there, though I think I moved through the code a bit quickly, the people there seemed to enjoy it as well, which was good. And this has gotten me really excited about finding something to build. Now, one way that you can learn to build compilers is to take a language specification that already exists and then start building compilers for that language specification. Take little bits of the language and build and build and build and build until you have 60% of the spec implemented. And then review. See if you like the way that you've started to build a compiler. See if it's fast enough for you. Think about ways to optimize. You generally don't build a complete compiler for a language that already exists, for compilers that already exist, because that's kind of a waste of time, right? You're better off contributing to those projects unless what you're trying to do is learn how to make compilers. And I really want to learn how to make compilers well. I don't know how to do that right now. But having said that, I realize that a fast compiler for a programming language is like a tiny part of what makes a programming language popular. And let me talk about this for a little bit, because I think it's an important thing to know. For the longest time, I didn't try and build compilers. And it's because I looked at people around me in PHP, predominantly, because that's the community that I've been part of for the longest. And what I saw was a few clever people, maybe 2 or 3, working on compiler theory stuff. So contributing to the PHP compiler, making their own compiler projects. And I looked at these people, and these are like really qualified people, and they've studied compiler theory, and they're really good at what they do. And I thought to myself, well, I haven't studied. I've worked at a few agencies. I've been fortunate enough to work for the Next guys in Cape Town. I've been fortunate enough to work for Silverstripe in Wellington. And what I've done is build websites with PHP and done some JavaScript and 1 or 2 other languages, but nothing as serious as building a compiler. And that's why I didn't try and build a compiler. Other people were doing it. I didn't think I knew enough. And when I started experimenting with this, I realized actually the compiler is a very small part about, the compiler is a tiny part about the whole thing that makes a language popular. I'll give you an example of what I'm thinking about here. So the example is Coffeescript. Let me go to the website and I can show you a little bit of Coffeescript. Now, Coffeescript is a white space significant language. Looks like this. and it compiles to regular JavaScript. So this Coffeescript on the left-hand side here compiles to this bit of JavaScript on the right-hand side here. And the first compiler for Coffeescript arguably wasn't very good. It wasn't very good. Not that I'm the one that's saying that. It's just that many people far smarter than me have said it could be better. But Coffeescript is really popular. And I think it's because it had good documentation to start with, and it had good tooling for a brand new language. You can basically go to this website, click try Coffeescript, and experiment here. And there are now source maps, and there is syntax highlighting and IDE integration. So documentation, tooling, and then the third thing I think which made it popular is a community, like a vast community of people using it and building libraries on top of it that work with Coffeescript. And so in the grand scheme of things, like all of these forces work together to make Coffeescript popular, even if the compiler itself, as a first attempt, wasn't very fast or very good. The whole community around Coffeescript built it up to a point where there have since been a few attempts to rewrite the compiler, and they've happened with varying degrees of success. But it's a small thing, right? It's a small thing. The compiler is a tiny bit of what makes a language popular. And so once I realized that, and that I didn't actually have to be the smartest person in the room to try and build a compiler, I started experimenting with building a compiler. Turns out there are a couple of ways that you can do this. First is you can use a compiler generator, which basically means you need to learn some kind of DSL for this. So my favorite at the moment is peg.js. And peg.js is part of a series of tools that let you use a DSL to explain your language in terms of expressions. And then these expressions match source code. And so you put the expressions in the compiler, and you in the compiler generator, and you run a function, and the compiler generator will make for you a compiler to pass some source code. So you don't need to know how it's building that or what that compiler is actually doing. You just need to know how to express the language that you want in the DSL of the compiler generator. And it's great. Peg, by the way, stands for... Oh, yeah, there we go. No, actually, it doesn't say there. So peg stands for Parser Expression Grammar, I think. And this is one of a number of tools that do something very similar. They all have DSLs, and they all generate compilers. And so that's the one way that you can build a compiler for a new programming language. The other is to build a compiler by hand. And this is how compilers like PHP started, because, or the PHP interpreter or compiler, because Rasmus started making a compiler by hand, not using a compiler generator, and basically using pattern matching and string manipulation and a state machine to make it compile code. And that's the one that interests me. That's the tool that interests me the most, more than using a compiler generator. Because I appreciate the simplicity of being able to put some expressions in and get a compiler out of it. I appreciate that. But I actually want to understand what's going on underneath. What is the compiler actually doing? So all of my efforts have been in trying to figure out what a compiler actually does underneath, and in trying to work that out. The results of which are that I have a very, I guess, narrow understanding of how to build a compiler using string manipulation and pattern matching and a state machine, and I haven't really tested it out. I haven't taken a spec and tried to build a compiler for part of that spec. I've just learned a little bit of the theory to be able to pass a little bit of something and extrapolate that to varying degrees of a complex language. But now I want to actually make a language. I want to make a language. And so I think it's appropriate to define what I want this language to be able to do. Because for me, I'm building the language so that I have something on which to build a compiler. I don't want to use a spec because I don't want to partially implement a programming language. To me, that has less value than actually trying to implement a new language and kind of combining the two. So trying to design a language a little bit and then trying to build a compiler for that design. So that's the goal of it for me. But I can't translate that well into a general purpose programming language. That doesn't really give benefit to anyone else. And so what I'd like to do is I'd actually like to try and establish a guide for, or goals for the language that I'm making that would give it value for someone else. What I kind of want to do, so Pants for Birds asks, does the compiler generator use an algorithm similar to the shunting yard? And Pants for Birds, I don't know what that is. The compiler generator, I assume, converts the DSL patterns that you define into regular expressions and uses a state machine for that. If I was building a compiler generator, that's what I would do. But they potentially work in many and varied ways. So I don't know Peg.js specifically, whether it uses an algorithm similar to the shunting yard. But I'll remind you, I don't actually have compiler theory education, so I probably would have heard that term if I had, and I haven't heard that term. If you feel keen, perhaps explain it, or maybe maybe this is a good opportunity to Wikipedia it up. Shunting yard, I'll go. Is that? It's kind of zoomed out. Here we go. Let's have a look what this is. Oh no, I've started PHP Storm. Force quit PHP Storm. Okay. Is a method for passing mathematical expressions specified in infix notation. So, what does some of this notation look like? Okay, so I think that I don't know, to be honest. I don't know. This kind of makes a bit of sense to me, but I don't know whether Peg.js specifically or one of the many and varied compiler generators use that method for analyzing language. I'm not going to. I'm not going to. So back to setting goals. Okay, what do I want the goal of this thing to be for other people? Because I know what the goal is for me, but what do I want the language to be really good at? What's the language's focus? I think a good focus to have is... Well, I was thinking about this earlier, and what I thought was that perhaps a really good focus to have would be that beginners can pick it up easily and find it difficult to screw stuff up. Now, yeah, so thanks. So Pants for Bird says Shunting Yard converts expressions to reverse Polish notation and then evaluates it using a stack. So I don't think so. Yeah, that's kind of very eloquently expressed. But yeah, I don't think the compilers that I am familiar with work like that, and the compiler generators, who knows? That's kind of the beauty of the compiler generator, is that whatever it generates and how it works that out, as long as you are aware of the limitations of the languages it can parse, it can kind of do that however it wants, which is part of the magic that happens to get this stuff to work so quickly, but you also lose that understanding. And I want to be able to understand what shunting yard means. I want to be able to know the tricks that go on inside these compilers that the compiler generators make. So that's the thing. Okay, so focus. Beginners can pick it up easily and find it difficult to make mistakes. I think that's an interesting goal, because one of the things I really enjoy doing is writing tutorials for people about programming, and just trying to disambiguate the complexities of a language take up a lot of effort or energy, I guess, and if I can explain a language without having to say avoid this part of the language and avoid this part of the language, that seems like a good thing, right? I kind of want to have a number of things, and let me just change this to important things. So this is the main thing. I want beginners to be able to pick the language up easily and find it difficult to make mistakes in the language. I think that's the main thing. So technical considerations for the language. Water. Technical considerations for the language, keyword usage, all that kind of stuff. The main question is whether it will be easy for a beginner to pick up and whether it can easily be abused. Now, essentially that means making something with as little language as possible, making something as simple as possible. And I think that's possible. The second thing is that I really advocate testing. I really like testing. And I would like the language helps people write tests. Now that's very vague. But I kind of have an idea about how I want that to happen. I kind of have an idea. Two things, which I'll explain in a little bit. So are there any other important things I want for this language? Let me make these 2 points. Okay, beginners can pick it up easily. Beginners find it difficult to make mistakes in the language. The language helps people write tests. Anything else? The language compiles to widely supported to other widely supported languages. Okay, let me explain this a little bit. I do a lot of PHP, as I've mentioned, and I think one of the reasons that PHP became so popular and continues to be so popular is because of the amount of effort Rasmus put into making it run everywhere. He didn't just work on the language and design the language to be brilliant on its own and like work on a massive standard library. What he did was it started as a simple templating language, but he got it to work with Apache. So it saved him some time because he was doing forms in C at the time, and he got PHP to work with Apache. That was the first thing. Then he got PHP to work with common databases, and at the time it was MySQL. And so every kind of bit that he bolted onto PHP, every significant bit of work was focused on interoperability, on getting the language to work nicely with all the other techs of the time. And this is what got it. This is what got it to be so popular. I think it was competing with Perl, and Perl, I guess some would argue, is a superior language in terms of just the language itself. But PHP just worked in more places, and it had a share nothing architecture, and it was safe to run on shared hosts, and it worked with MySQL, and all these things helped to make it popular. I think at least that's what Rasmus describes as its meteoric rise to popularity. Now, I don't want to make just an interpreter that takes this language and tries to run it, because I'm going to be writing this in JavaScript or in PHP. It can't actually keep a runtime up in those languages, I don't think. I just don't manage memory well enough to keep a runtime up in those languages. But I think it would be wise to make any kind of language that I make here able to compile to PHP or to JavaScript, because those already have wide market adoption. If I could say to people, similarly to how Coffeescript worked, write in this language, and you can still use all the other libraries you've already been using, but you can write in this language, and this language will compile to that. And so you can have the format and the syntax and the architecture that you want, and it's just going to work. There's going to be a runtime to run the stuff in PHP. There's going to be some kind of compilation process. It'll work nicely, and you don't have to change your server hardware. You don't have to run new versions of PHP, though it's probably going to require pretty recent versions of PHP. You can just run the code. I think that's a really good thing. So I think this is good for goals. Beginners can pick it up easily. In other words, if I'm showing it to people, if new programmers want to learn, it's got to be an easy language for them to learn. That means reducing complexity. That means eliminating many and varied options. That means hiding dangerous parts of the language. Then beginners find it difficult to make mistakes in the language. What does the language do to help people who are making expected mistakes? Does it go to pains to remove commonly made mistakes? Does it document stuff very well? These are all kind of important things, I think, for this language. The language helps people write tests. What does the language do to force people to write tests? What does it do to encourage them to write tests? What does it have in the language in terms of keywords and constructs that lean towards tests? Do you have to split tests off? How do you structure tests? Is there a recommendation? Are there required architectures for it? What do we do there? And then the language compiles to other widely supported languages. I don't want to make a runtime. I don't want to make a JVM. What I want to do is I want to make a compiler, a cross compiler, in exactly the same way as Coffeescript works. It takes this new language and it converts it to JavaScript so it can run on Node, it converts it to PHP so it can run on Apache or Nginx. That's the goal. I think that's the goal. Now, that's good. So we've got a list of things that we can consider important. I think for the moment, though, I'm going to take a quick break. So just for 2 minutes, and then we'll come back and talk about this more. So enjoy some music. See you now.